I put this over here. All right.
Make sure microphone's on.
Is it on?
Scare.
Okay, so I think all of you have heard of RxJS. Some of you are using it. As far as I know, only Gary's using it though, is that right? Anyone else here? Okay. So, yeah, I haven't been using it all that long, but I've used another two libraries which are similar called HighlandJS and BaconJS. I've been using them about a year, but RxJS maybe several months. When I came to this project, it seemed a very natural fit for all the API stuff that we were doing. So let me tell you what it is. I'll give you some backstory. The story starts with this guy here. Yes, Eric Meyer, and he always wears tie-dye t-shirts, and I don't know if he does them himself. He may very well do. He is one of the designers of the Haskell programming language. So if you're aware of Haskell, he was part of a team that designed it.
Looks like Jordan with less hair.
He's Dutch. He's Dutch. He's got another exotic accent. Yeah. So yeah, that was Haskell was I think 1990. So he was working on this in the 90s, and then in 2000 he joined Microsoft. Simon Peyton-Jones, another one of the Haskell guys, was at Microsoft doing research there, and so Eric Meyer went there. He said he wanted to move away from academia because he wasn't writing real sort of code and he was sort of designing languages, but he wanted to work on real problems. I have a slide of a function here. I didn't know how it fits into my story exactly, but you know, he's interested in pure functional programming languages. So that means programming with mathematical functions. So a function has an input and an output. It looks like that. It kind of frames what comes next. So yeah, he went to Microsoft, and then it seems to have taken him a long time. But while he was there in 2007, he introduced a thing called LINQ. It was for .NET. And I'll explain what it is. So LINQ is kind of like a better version of underscore, or better version of Lodash, if you like. It's an API for manipulating any kind of data collection. So the problem he was trying to solve was that programmers were having to deal with all kinds of different data sources. So they might be querying SQL databases. They might be working with XML and using something like XPath. They might be working with JSON. They might be working with objects. They might be working with all kinds of things. And the kinds of querying you need to do, it's all kind of similar, but you have to use a bespoke API each time you work with each kind of language. So he developed this thing called LINQ, which is like a higher level of abstraction, and you sort of feed.
Sorry, I think you're muted here.
Oh, really? Oh no.
It's probably on the wrong hangout.
Are you on the wrong hangout? I can't hear us. How can I talk with this person? Where is that? Hey.
Yeah.
Hello, can you hear us?
Yay!
Hey, sorry.
There's two hangouts running, that's why.
Okay, so all he missed was Eric Meyer. He was one of the developers of Haskell. He went to Microsoft and he developed a thing called LINQ. And I'll pick it up from there.
Will they have the slides up there in their own one?
They're probably viewing both.
Okay.
Are you guys seeing the slides, guys?
We need talking rather than hand gestures.
Hello.
Yeah, well, I was following with the slides separately, but I can see them.
Okay, because there's a separate hangout for the slides as well.
Should I kill one of them? Oh no, it's already on the air.
Yeah,
Okay.
yeah.
All right. Okay. So yeah, we're on slide 11. Yeah. So LINQ, it uses high order functions to compose functionality together, so that you can work with any kind of data collection with a single API. So you're not having to shift between different querying syntaxes or semantics. And it uses functional programming concepts. So you might be familiar with a lot of these things. They've now found themselves into JavaScript, but I'll just do a recap. So map, for example, lets you take a collection, you pass in a function, which gets applied to each element in the collection, right? So here I pass in a function x, which returns x plus 2, and I get a new collection, 3 to 6. So all of these higher order functions, map and filter and so on, are sort of the building blocks for LINQ. Filter is another common one. You're probably using it right now. But in this case, I have an array, and I pass in a single function, which only takes a single input and returns true or false if that number is greater than 2. And that results in a new collection, 3 to 4. Reduce is another common one. It's also in JavaScript. So here I've got two functions. One is called sum, but it could just as well be called add. And this lets us insert a function in between each element in the array, which reduces the array down to, in this case, 10. It's just adding all those numbers up together, and we get 10. Similarly, we have a function here called max. So when we pass that into reduce, it just takes 2 numbers and returns the highest number of the 2, resulting in 4. Flat map, you might not be familiar with. It's not in JavaScript, but what it does is you pass in a function which returns the collection itself. So what you then have is a collection of collections, which then get flattened. So in our case, if you pass in a single x into a function called to 2 numbers, it returns an array with x, and then the same number plus 1. So if you calculate that out, we here have an array of an array 1 and 2, 2 and 3, 3 and 4, 4 and 5, and then it flattens that out to a larger array like this. So this is a really important pattern in RX, well, in LINQ initially. So just to recap about LINQ. So I've shown you 4 higher order functions, but there's a whole range of them, and it makes querying and working with data really easy. And you don't need to know about the underlying data structure, where the data came from. It just gets funneled into LINQ, and then you can use these things to query the data, and you can output into whatever format you want. The idea is that it's declarative, so you focus on what you want to do, not how you want to do it. You don't have to spend all your time creating for loops or creating variables to store things during your calculation. Doing your calculations, and it allows composition. So you can compose and chain all of these functions together to manipulate data. Now, what's quite smart about LINQ is it's lazy. It has a lazy evaluation. So if you have a chain of functions, if you don't actually print or do anything with the data at the end of it, no calculation actually gets made. And I don't believe underscore does anything like that. So with underscore, it will always be performing everything as it goes through a chain.
It's a lazy version.
Yeah, so it's a lot more performant. And it's parallelizable. So one of the important consideration was that as we move to multiple CPU cores, a lot of standard algorithms or computations can't be split very easily between different CPUs because of the way memory is shared and so on. But when you have a map function that gets applied across a collection, you can farm 1 quarter to that CPU, 1 quarter to that CPU, and you can pull the results in later. So you don't have to make the programmer think about how it's going to get parallelized. You get it for free. Okay, so not very long later, 2009. Came something new, and it's quite a bright idea, and it's this. So if an array is a collection of values, are events a collection of values in time? takes a little while for that to sink in about what that means, but I'll try to explain what that means. But it's quite interesting. So here's an array, 1, 2, 3, 4. Now, suppose we have a user who's clicking the mouse on a screen. They click again. After some time, they click again, and then they click again. Now, that's kind of array-shaped, spread out through time. Now, suppose we can use our old friend's map, and let's say we map the number 1 to each of these events. We now have a collection of ones through time. Now, if we use this other higher order function called scan, which is very much like reduce, so we're passing in add, but what it does is it evaluates each time an event fires to produce a new number. We then get something like our original array, 1, 2, 3, 4. So this is kind of the key insight behind RX. So RX was a library for .NET as well. The full name is Reactive Extensions. I'll talk more about it and give you more examples so you understand what's going on. But the idea is you can use all those higher order functions and model that was used in LINQ on event streams. And that's why it's so powerful for asynchronous programming. So it's kind of a cool idea. Again, it takes a little while for that to sink in about what it means and how you can use it. But here's an example. This is taken from a introduction to reactive programming. There's a link at the end of the deck. But here's a challenge. If you create an event stream for each instance of the user clicking the mouse in quick succession. So what I mean by that is they're clicking on the screen, and then you want to fire some callback, say every time you do a double click. And that's not one click followed by 2 seconds by another click. It's quickly, right? Or 3 clicks or 4 clicks or so on. Now, if you think for a moment, how would you approach that? How would you implement that without using something like these here? It's non-trivial. It's pretty involved. You're going to use a lot of set timeouts, or some set timeouts, and you'll be clearing those and waiting for those to expire and so on. You'll have some variable, perhaps, which captures how many times a thing has been clicked, and you'll have to count that up. And then you'll have to take a callback in and allow it to be called at the right time. It's not trivial. But with RX, it becomes 4 lines of code. It looks something like this. So this line here represents a stream of clicks, and they're different colors just to represent different clicks. But if we use throttle, which and we've got a 250 milliseconds, so we're waiting for it will bunch up events that occur within a 250 millisecond time frame and produce a new collection of events. And then we buffer those collections together. So what we get is a collection of collections. So here we've got a single click. These 2 here have been buffered together. Then we've got 1 by itself, and these 3 have been buffered together. Then we simply map a function on top of those collections to get the length of those collections. So the first one is 1, the next one is 2, and then 1, and then 3. And then we can just filter out all of those the single clicks. And now we have an event stream of 2 and 3 clicks. And then you can have some function which calls on every event and every event in that stream. Again, it takes some time playing with it to actually get a feel for how this works and how you can use it. But it's really quite powerful, and it makes what might otherwise be really complex code much more straightforward. So I'll take you through some examples now to do with movies and ones that we're using on the movies page. We don't do this one, but it's useful as a simple example. So suppose we want to print 10 movies starting with the letter N. So suppose we have some function which gets all movies, and we do have that. There's an API for that, so we can just get a list of all movies. But that doesn't give us all the details for all the movies. It gives us let's say it just gives us a title for now. That's all we really need for this example. So pluck is another function which will take, we'll go through every element in the collection, and we'll take a property that's in one of those elements. So we're assuming here that there's an element in there which has a thing called title, and we just pluck that out. So now we get a new stream of titles. Okay, so it's just it's a bit like an array, just full of titles. And then we just filter out those that we aren't interested in. So we're only getting those that start with the letter N. So we have a new stream of movie titles that start with letter N. And then we take 10, and then we use for each to console log them to the screen. So I hope that makes sense. So a slightly more complex version, movie search. So what the search team give us is an API for taking a string, and we get back a... Yeah, sorry. Yeah.
So on the previous example, what do you think is really helpful? I mean, where Rx is really useful, because it feels to be just regular functional programming code.
Say again?
And I'm asking in this get all movies,
yeah.
You printed them. What is it that Rx helped you with here? Because it seems to be just regular functional programming practice.
So I mean, that's kind of what Rx is, right? It's just functional programming practices provided in a convenient API. In fact, the only asynchronous thing happening here is get all movies, and Rx, I mean, is not being particularly helpful in this example. But what is helpful is the chaining of events, of being able to manipulate the data, and all of those things, pluck, filter, take for each. I mean, those were available in LINQ. This one is quite a simple example. But let me show you some further examples to show where it becomes a bit more powerful.
Thanks.
Yeah. But yeah, please ask questions as I go. No worries. So for movie search, so this is really what we do. There's a API which gives us entities which match the search term, which aren't just movies. There's programs, there's series, there's people in there. It would be quite nice if we could just say and type equals movie and we get movies back, but that's not how it's built at the moment. So, and we have a function called get suggestions for. All that does is it takes a search term and it makes an HTTP request and gets search results back, right? But they come back presented as a collection, Rx collection. So, so after the first line, we now have a stream of suggestions, matches. Now I want to filter out only the movies. So now I have a stream of movies. Now, what I want here is a UUID, because I think we just get the title and the UUID. So I pluck out the UUID, which gives us a stream of UUIDs of movies. I take 20. That just takes the first 20 things in a stream and ignores everything after that point. Now, here's where FlatMap becomes really helpful. So I have another function called get details for film. Now, what this function does is it takes a UUID and it makes 2 HTTP requests, and then it merges the results of those into a single object which represents the fully expanded out movie. I'll show you what that code looks like in a moment. But it's a stream, and FlatMap is going through each of the UUIDs and calling this function, which is an asynchronous thing, and it waits for those all to come back and all to resolve, and then it presents the results of that as a stream, which I can then convert to an array. If you didn't use something like this, again, think about how you do it. It's not trivial. There are some libraries out there. There's like the async library is quite popular for a while. But if you were doing it manually, if you had to make 20 HTTP requests, well, actually it's 40 HTTP requests because we have to call 2 APIs to get all the information for a single movie. We don't have a single API at the moment that can go to one place to get all the information for a movie. You have to go to 2 places. So you'd have to make 40 HTTP requests. You'd have to store the results somewhere. And you'd have to continuously check to see whether they've completed. And only when all of them have come back can you then flatten them out. So the search really is as simple as this, and how we actually implemented it, we already had this get details for film function because we were using it for to expand out the tiles. So if you remember, Tomorrowland is the first tile. That's just represented by a UUID. So we use this function to go after those two endpoints to get all the details so we could put it in the movie tile. So when we came to search, it actually took 5 minutes to implement search because it was just these lines here. So it takes a little while to absorb and understand how you can use this, but it does make working with asynchronous things quite a lot simpler than it would otherwise be. Yeah, John.
So I mean, this is a really nice kind of like API to use. I guess one concern I have is that RX is great when you're dealing with kind of like continuous streams, like user input, but with HTTP requests, we're very aware of their life cycle. I mean, it's polling based right now. A lot of RX functionality is based on the idea of continuous streams and operant on those. We've not got a very continuous stream. Do you believe that the overhead of that is still worth RX over more, like for example, like Bluebird, which is a Promise utility library, which also offers something similar to this?
You're talking about in the browser?
No, both situations really.
Yeah. In a couple of slides, I'm going to talk about promises and the relationship of this to promises. So let me address it when we get to there. Okay, I'll move on to the next example. So basically, this is the code that lives inside the get details for film, the function which takes a UUID and expands it out into an actual object. It is simplified a bit because I haven't showed all the fields, but here I'm using a utility function called zip, and what that does is it takes two asynchronous streams and a function, and it decides how to merge those together into a single stream. As it happens, these a call to API A and API B only return one result. So you could use a promise in those cases. You could use 3 promises, so one to wrap 2 promises inside, something along those lines. But this is fairly convenient. I can make a call to API A, API B. I get the results for both inside the function, and then I can decide which elements I want from each of those 2 requests, and I return it. And then I can convert the whole thing to an array once I'm done. So it becomes quite trivial. So yeah, as it happened, we get the title and the rating from the first API. We get the release here from the second API.
In actual real terms,
yeah,
this is outside of RX. Is API B the old search API?
No, they're both 2 different kinds of searches that you do with the entity API.
You're doing the entity search and the entity type. Yes.
There's the search, which is the ways to watch, and then there's a program details.
It's based on UUID type.
But I think the only thing that we're missing was the release here from API B. So they could do some work to I mean, we were trying to make the prototype work with the tools that were there, but we've made a list of a lot of things that they could change on their end to make our job a lot more efficient.
And less hits for them.
Yeah. Okay, so now I'll talk about the genre collection. So if you remember, you just have all that we specify is a genre name, and that auto generates a list of movies. So this is how it works. So the first function here, get movies for genre sci-fi. There's an API which we can get all the movies filtered by genre type. So we just pass in sci-fi on that API, and it'll return back all the movies. But without all the details, just a UUID and a title. So it's very similar to the search. So we just pluck the UUID out, and then we pass each UUID through this get details for film, the same function we saw before. So once that's completed, then that will give us a list of all the movies with all the details. Then we sort. So here we're sorting by rating. So there's Rotten Tomato score rating. I realize in my example that I've got these lines the wrong way around because I do the flat mapping. Oh, sorry, no, I've got it right. Unfortunately, it's a bit inefficient. I've had to call all the details for all the movies just to get the ratings. to be able to do the sorting. So that's very inefficient. We don't want to be doing that on production. Then I take 20, and then I shuffle them, and then I convert it to an array so that I can consume it. Now, the reason why these two are red is because, unfortunately, RX doesn't actually implement those methods. Link does, but they haven't been ported over to RX. So, I mean, I see that as a kind of omission in RX. I don't see why they couldn't be in there. They have other similar functions like max. In practice, we can write our own versions. They're just another couple of lines, but it would be quite nice if they had those convenience functions in there.
Is it extensible so that you can put them in the chain?
So maybe they don't advertise that. They don't say, here's how you can easily extend it.
So if you do the RX tutorial, there's an online tutorial, it's brilliant. It's like 40 or 50 different examples, and they get you to write each of the components of RX, and you actually learn how not only to use RX, but also how RX is implemented, and it is quite flexible.
Okay. Highland.js, I'll talk about it later, but it has some, it's a little bit more convenient to add your own things in, I've found. Right.
I'm not totally surprised it's not implemented though, because how do you want this string to behave? Because you're messing up with the order, so you probably need to be some kind of batching time so that you can make a decision. I have enough to shuffle, I have enough to.
So there's an important thing to mention, actually. It's a good point about streams. Streams can have ending event, so a terminating event. So those would only work on the cases where there is a terminating event. So when the event terminates, when the stream terminates, at that point you perform your sorting and you do your shuffling.
Well, I think it kind of comes down to possibly the idea of if RX is mainly for continuous streams, shutting down a continuous stream is probably not in their top priorities to do.
Yeah.
So it's also source mutate as well.
Yeah. So anyway, you can do it yourself. You just convert it to an array, you can sort it, and then you can put it back as a stream. Yeah, outside Microsoft, the biggest users that I'm aware of and contributors to RX are Netflix.
Yeah, exactly.
So they created the Java port of RX, and they're using it quite heavily both in Java and JavaScript, and they do a lot of talks on it. If you go online, you can see a lot of talks by their guys about RX. Right, now, relationship to promises. This diagram is a little bit difficult to digest, but Eric Meyer shares it quite a bit. So if we look at this table, we've got, if you picture like in the first column here, if you're dealing with one thing, sorry, that's plural, it shouldn't be. And here we've got collections of things. And on the rows, we've got synchronous calls and asynchronous calls. So if you take the first example, one thing, a value, a single value, let's say it's a string. Sorry, I think I've got code examples coming in one moment. What I wanted to say first of all was that there's a missing box down here, and that's what happens if you have a collection of things that have to resolve in the future. I'll show code examples to explain, but that's where these event streams fit in, and it's where they differ from promises. I'll show you some code examples so that you understand what that means. So let's say you have a movie which is just a string. Let's just say it's the name of a movie. It's a string. You can use it how you like. It's synchronous, so this console.log needs to resolve before anything after it will work. Now, in the next example, we have an array of strings. So that's just a standard old array, and we can use for each to log all of those movie names out to the console. This text under here is supposed to be the type signature of a promise. So when you're dealing with promises, you call a function. You don't get that string back immediately. You get the promise of a string later. So the type signature is different from a synchronous string. So here we've got get movie. When it resolves using then it console logs. But you only get one. And that's the key limitation of promises. You only get one thing. Let's say we have a feature on the website where every time a movie becomes available, you get a little pop-up. It'll be an irritating feature, but you get a little pop-up saying this movie has just been released, right? If you're using promises, you'll have to continuously create new promises so that every time a new movie becomes available, you can print it to the screen. But event streams are very much like promises, but it's a collection, and it can be an infinite collection. And it works like this: get movie stream, and for each, which is what we're using on the array here, console log, but that will only fire. It's kind of like on new movie stream event. It will only fire each time there's a new movie. So that's the key difference between promises. Promises only happen once. Event streams happen multiple times.
I mean, so I get that.
Yeah.
And obviously, the collection of things where it's an event stream is yes, where it's kind of continuous, but it's a bit. I mean, to me.
Yep.
In the movie example, it's still one thing because rather than get movies, but we're still getting them in batch. We know exactly when it starts, exactly when it finishes, because it's a whole operation.
Effectively, you could replace all the RX stuff with PromiSol, then flag map it, then.
I mean, that's the thing, really. I mean, because it is still, it's pull based. I mean, streams work great when it's push based, like user input. Do you believe, and I really like the RX API after that fact, but it seems like we're doing a lot of work to change the promise into an observable. Do you believe that there is a library or functions out there which have that nice chainable API, but on pull-based promises, is what I'm wondering, because that seems like we could then replace that with RX for movies at least, and we might investigate RX when we have stream push-based stuff. That's what I'm considering.
I'm just trying to think how different that would be from using RX anyway. Like I'm just trying to think what advantages you would get of such an API. I mean, this is kind of it.
I mean,
this wouldn't be converting to the stream and back again for no reason.
Yeah, I mean, that is overhead of from a kind of a conceptual point of view. We have a single concern that here's my promise and here's the utility functions on that, as opposed to we have two. If we use RX, we've got a lot of functionality that we're bundling in, but never using because the search is a HTTP pull request, and we're having a lot of overhead of kind of faking a continuous stream, terminating it, converting that to an observable, and then doing all those chains. And that's what I'm wondering if I completely love the idea of this kind of these like sort filter take.
Go ahead.
Do you really get an overhead with this? Because essentially stream processing can do finite iterable processing, and in the end, if you think about the search API, actually I think it's a good one. What if all of a sudden they decide to make it paginated? In which case, using RX from the beginning would completely shield your logic from anything like this. Well, if you go with something simpler, you'll have actually when it starts being paginated to clutter your
I think I'd be open-minded. I mean, I'd be happy to find some other example. I don't know of one.
Yeah, exactly.
If you go find one and tell us about it, you can check it out. But as far as I'm aware, there is not a lot of overhead. It's the performance. There's a page which shows performance of this against Bluebird and some other libraries, so we should check that out because they do a lot of work to engineer it and fine-tune it. So I don't think the overhead's great. I should add that there is pagination, and in fact, I did implement pagination, and it was fairly trivial. I had one stream which represented the first call, and I had another stream which represented all the subsequent calls that I needed to make. I can show that to you later if you like.
Yeah, I mean, it's really interesting.
Yeah.
I think it's just a concern both from a kind of performance overhead, but also kind of a isolation of concerns. Are we having a large scope, which is all streams, when actually our problem's only a slice of that? And are we introducing a large, essentially a kind of a hammer to screw in?
Maybe, and there is a bit of a conceptual overhead, and sometimes when you're trying to think in terms of streams, it gets hard. it's not very easy to place in your mind sort of when all of these things are going to resolve, and it can be quite tricky. And I have got into some sticky situations where just conceptually trying to understand what I'm trying to do is hard, and it's taken me a while to get to a point where I'm more comfortable doing it. So there is a learning overhead and a working overhead. It's true, and yeah.
Would most of those things be easy using promises? I mean, it's essentially
Possibly not.
once you
I don't
actually
think
enter
so.
that conceptual,
That's right.
the actual difficulty in the first place,
Yeah.
you're already getting to the point
Yeah,
where it's probably
The nature of the problem
promises.
requires that it is time-based, and yeah.
I mean, so we make heavy use of Ramda right now in a lot of the applications, and obviously it's because of the way, the nature of the thing, the nicety that this and the API have like this, the chaining functionality. Obviously in Ramda, rather than chaining, you get the giant, the very long function calls.
Yeah.
But it's got compose for it.
Yes, yeah, and that's where I'm wondering, introducing a library that has for a very similar an overlap.
Yeah.
And it's just like.
So there's another thing which I didn't really. I don't want to derail the conversation, but
Yeah.
So in object pattern speak, this is the observable, and this is the iterable, and Link is all about the iterable, and RX is all about the observable, and they're using the same API, just with observables instead of iterables, and that's the kind of brilliant insight in it. But because these are synchronous, sometimes in your code you're writing synchronous stuff. You don't need the power of the asynchronicity, and I found sometimes I'm doing asynchronous stuff, but then I have an actual array and I want to do stuff to the array, and it's too much to use RX to do that stuff, and I'm falling back to using JavaScript's own map and filter, and it's a bit weird that I'm using two APIs to do the same thing. If RX came with like an iterable and observable API in one, I might be using it, but sometimes you just need synchronous stuff. Yeah, I mean, the API that RX exposes, once you've learned it, it's very easy to do any kind of processing that you want. It is that one API, a bit like underscore or I haven't reused Ramda, to be honest, and Lodash, but yeah, I mean, that was the motivation though behind Link. Here's just one API for all your data processing needs. But RX takes it into the observable and to merge it with asynchronous stuff. Maybe I'll move on. Not too much left. Yeah, so it's called Reactive Extensions. That's the website. It was originally for .NET, but it's got ports to a lot of different programming languages, so you can check it out. I found the documentation is okay. There's quite a lot of it, and if you want to find a function, it's a little bit tricky. This website tries to document the RX API for all the languages in one place. And if you go to Google, there's all of that documentation lives in GitHub, but there's like maybe hundreds or at least dozens of GitHub pages, and they don't link very conveniently between each other. So I found this a little bit inconvenient. And sometimes there's no actual code examples of how you're supposed to use it. So you have to go elsewhere to find them. Yeah, so let me just talk about these other libraries. So I started out with Bacon.js, and that's when I first sort of encountered this streaming concept, and it was really very interesting. I won't get into details too much, but there's a thing called combined template. That's quite a nice feature in the language where you can you combine these asynchronous things down into objects. You can check that out. There's some nice convenience method in there. It's a bit verbose, and I found the documentation a bit annoying. It's all on one page, but it's not organized very nicely, and it was hard to find anything. Sometimes examples weren't great, so I moved on. Highland.js, it's more succinct. I call it a bit more beautiful. It's written by I don't know his whole name, but Cowland. He did the async library and he did Node Unit, so it's a prolific guy. But you know, it's written by a front-end developer. It's a bit more tasteful. It's nicer to look at. There's quite a lot of very convenient methods in there, like the sorting and stuff like that. The documentation I find a lot nicer. It's all on one page, but it's organized in a much more convenient way than Bacon. And so because it's on one page, you can just do a Command F on your browser and you can search for everything that exists in the language there. They don't have all the examples though as well. But I ran into problems with it. They've got this stream forking concept, and if you start composing different streams together, I don't know, I got stuck. Maybe there's easy ways to use it, but you're forced to either fork or observe a stream, and I found it to be quite inconvenient. And it was at that point where it was inconvenient compared to how I'd been doing it in Bacon.js. It was at that point where I thought, okay, I'm going to go to RX. I was aware of it. It seemed a bit bigger. There's obviously a lot more support behind RX. Didn't seem quite as nice looking as Highland.js, but I moved over to RX. And yeah, there's some things that annoy me about RX, but ultimately I can do everything I need in it, and I found it to be pretty good. Okay, I think this might be my last slide. Reactive programming versus functional reactive programming. You might hear these terms. If you go online and you want to read about these things, I think you'll find it, well, I found it was quite confusing. Functional reactive programming looks like it's related to reactive programming, but it's functional, but that's not the case. And Bacon.js calls itself a functional reactive programming library, but according to others, it's not. So they're two separately derived things. Reactive programming, at least in terms of this ReactiveX style event stream programming, that's derived from Eric Meyer. And it was LINQ in RX, and that's where it comes from. And the term reactive programming itself is a bit nebulous as well, because that pre-existed RX, and it is just a general term used to describe certain programming paradigms. So it's a bit confusing. But Wikipedia says that it's RX. Now, functional reactive programming is just as functional as reactive programming stuff, but it's got a different derivation. It's from a guy called Conal Elliott. It's also equally interesting. He was using it to initially work with animations in a functional way, but he's trying to solve the problem to do with time and how time becomes a first-class citizen in programming languages. It's really interesting. I think, and he seems a really, really nice person if you watch his videos, but I think the way he describes things is a little bit inaccessible, and it's a bit difficult to follow exactly what he means sometimes. But it's interesting if you check it out. There's a programming language called Elm, which is influenced by it as well. It's quite interesting. But yeah, as I understand it, React is called React because of reactive programming. So it's, they're all kind of linked. Eric Meyer is at Facebook now. He hasn't been there very long, but he's trying to make the world better through functional programming. That's it. Any questions?
Yeah,
I'm interested to know about you guys, because I know you guys have been working with it.
That tutorial. It's
Okay.
really, really good, especially when it talks about things like reformatting data using concat map.
Yeah.
Because one thing that a lot of people tend to do with data is they tend to they get tired of manipulating it.
Yeah.
So what they do is they remove a lot of indentation from it, and they stop making it as nested as it could be.
Okay.
And if you look at the data that Netflix has,
Yeah.
it's extremely nested and well organized.
Right.
And it's designed, and if you use concat map,
Yeah.
you can very quickly transform multiple sets of data streams into the data that you actually want.
Yeah.
And the tutorial that they've kind of got this 40 bit. They kind of got 40-point tutorial that takes you through RX,
Yeah.
and it is absolutely fantastic. I mean, every single step you go through, for a start, all the ones they go through at the beginning, they're teaching you how to write those functions yourself. So they're teaching you fundamentally how RX works.
Admittedly, I've not been on that, and I might check it out. But yeah, concat map, we use that quite extensively. It's the same as flat map, but it preserves the order of the original array, which I didn't know about originally. I was using flat map because I think in the other languages it does preserve the order, but here it doesn't. And the movies were coming back in the wrong order. And
Flat
so
map kind of based on the streams into the order.
it merges them back in the order that they resolve. So it ignores the order. Yeah. the content map will remember the
Some
order.
funny things with ordering as well. I can't remember what they all are, but you can choose all kinds of patterns based on various different ordering modes. It is.
We always use problem solve to preserve the order.
Sorry?
Oh no, not problem solve. What do we use to preserve the order? No, it is problem solve.
Yeah, I think it's really interesting. I think it'd be worth investigating.
I think we should go compare it to Randa and find the line where one stops and the other stops.
But I don't think they compete.
Sorry?
I don't think there is a big overlap between Lambda and RX. I think I would recommend if you want to give it a go, and I think we should because it's almost a standard paradigm for an engineer in 2016. You can play with Sky Analytics and this; it could be quite fun. And I would also recommend you guys to give it a go with a statically typed language because the complexity you mentioned, Jonathan, I think I've been there. And this is where you like to have a compiler that tell you whether you have a stream of a stream of a stream or just a stream of a stream. And this is the kind of stuff where, yes, I think a good compiler with a proper type system can be really helpful.
Okay. Luca, nice to meet you, first of all. What have you been using RX to do?
Yeah. Okay. Can you hear me?
Yeah.
Cool. So yeah, we've used the RX basically on all the analytics pipeline in the first place because we have this stream of events coming from Kafka. So that's probably the best usage of RX in general. And it looks like well, it helps us a lot to basically do the counters. So we have some services that counts events based on an attribute or rules in general. So we perform these type of operations on the data that comes through a stream, and we republish using the same stream, Kafka.
Okay.
So basically, it's all a subscription, sort of a chain of events that is fired through the whole pipeline of Kafka. And what Kafka Utils does, which is the library that's shared across all these microservices, basically exposing a stream that's already automatically sort of decoding itself if it's Avro encoded, because we have this sort of schema that compresses the data that travels through Kafka. And we have this library that exposes strings to read from Kafka, so it automatically decodes these schemas or encodes them if you want to publish to Kafka. So we tend to use streams across all the things that we have done pretty much.
Okay.
Mostly because it's all asynchronous. And I also use personally on like you did basically on APIs that needs or that has lots of asynchronicity, or where you have many promises, chain of promises, or you have to use promise all every time. Like things like that makes you think that like RX in general for me has been more. Once you get used to it, it's more readable and it's more flattened, and so it's easy as well to move your logic from a place to another.
Okay.
So yeah.
Thanks.
I guess I see the overlap in a certain way of Ramda because Ramda is more for synchronous operation, for what I've understood on arrays pretty much. But yeah, the only problem that I don't like, I like that the fact that streams are lazy, so they won't be executed if there are no subscribers. But on the other side, I would like to have a sort of easy way to substitute things like Ramda in that sense. Let's say just have something that's if I input an array, I don't want it to be lazy. It's probably doable with casting it to array at the end, like we were saying before. But yeah, it's probably too much.
I've run into the same problem. That's where I want to continue to use the same API, but when I'm back in synchronous, I want to do synchronous operation. I can't use the streaming unless I do a bunch of merging later, and that's a little bit inconvenient.
Yeah.
Was that Hubert speaking earlier? Before that?
Sorry?
Was it before you were speaking? Was that Hubert? Was it you speaking, Hubert?
You're muted.
Yes, It's just because I need to switch to something in Windows. Yes, that was me speaking.
Oh, and have you been using RX as well, Hubert?
No, actually, I haven't used RX, but I've used some equivalent
Okay.
Scala.
Okay.
With processing all that.
Okay, I see. Okay, cool. All right. Cool. Okay, I guess we're done. Thanks, guys. Cheers.
Thank you.
Thanks. Okay, so let's do this. How do I stop broadcast?